Okay, so here we have our pretest over these couple of ideas geometrically. I gave this in class today on Monday. Let's see what the answers are. Okay, two similar solids have a scale factor, right? Anytime we have similar solids, you need to be solving this with a proportion. All of the similar solids are solved with proportions. Okay, we are given the scale factor. So we're given a scale factor of 2 to 7, but yet we're asked to find an area. So we cannot find an area with a scale factor. We have to change our scale factor into an area ratio. And you do that by squaring your scale factor. Area is a squared unit, so the area ratio will be the square of the scale factor. So 2 squared is 4 and 7 squared is 49. So we're going to use 4 and 49 in your proportion. 4 over 49. So it says the smaller solid is 52. So we put 52 in the numerator, and we're looking for the surface area of the larger one. So we put that into the denominator. So we cross multiply 52 times 49 and divide that number by 4, and you get a large surface area of 637 square units. So number 2 is done similarly. Okay, it says we have the surface area of a similar, right here we have similarity, so we need to make sure we have our proportion. So we are given areas of 200 and 242, so that is our proportion. Our actual areas are 200 and 242. Okay, so our first thing we want to do is change this into a ratio. Okay, so we need to have an area ratio, and notice 200 is not a perfect square, but maybe if we reduce these guys, you'll get something. So both 200 and 242 are even numbers. I can definitely divide them both by 2, and that gives me 100 to 121. Okay, maybe those numbers are more recognizable. So this is in fact your area ratio. Okay, because if I want to solve a problem that says volume, I have to go from area to volume. And I can't do that unless I go through scale factor. You have to go from area to scale factor, which would be 10 to 11, because you take the square root of both of these things. 10 to 11 is my scale factor. And now that I have scale factor, I can go to volume ratio, which is 10 cubed to 11 cubed. So 10 cubed is 1,000, 11 cubed is 1331. Okay, so anytime you're given anything other than scale factor, you have to do the scale factor first. So you take your areas, you reduce them to something that is perfectly square rootable, and then you square root it to get your scale factor, and then we cube it to get the volume. Because now that I have my ratio of 1,000 over 1331, I have the volume of the larger blob is 333, and I'm going to find the volume of the smaller blob. So I do 1,000 times 333 and divide that by 1331. And my calculator doesn't like that, so I have to Control Enter to get 250.188 cubic inches as the volume of that smaller gelatinous blob. Okay, so now we have these words as a function of, right? So we have two ideas. One is the perimeter of a square. So that's our first equation. Perimeter of a square is 4 times the side length, because it's a square, so all the sides are the same. And then it says a function of its area. Well, the area of a square is x squared, or side squared. So notice they both have an x in common. So I want to erase or replace the x in perimeter. So I'm going to solve for x in area. And the area, or the side length, is found by taking the square root of whatever the area is. Right? If I have an area of 49, that means there's a side length of 7. And I'm going to take this and I'm going to put it right there. So no longer is it 4x, it is 4 times the square root of a. And that's how I would find the perimeter, not a. I would find perimeter by doing 4 times the square root of the area. Okay, and similarly for the one down here, diameter of a circle. We know that the diameter is equal to 2 times the radius, right? That's our diameter formula. Diameter is 2 times the radius. But circumference is 2 times pi times the radius, 2 pi r. Right? So notice these both have the variable r in common. This one has an r and that one's an r. They're both related to radius. So over here with circumference, I'm going to solve this for radius. And the radius is the circumference divided by 2 pi. And that comes over here into my diameter formula. Circumference divided by 2 pi, and I'm still multiplying that by 2. So hopefully you know if I have a 2 on the outside and the 2 on the bottom, then they cancel out. So the diameter of your circle is found by doing the circumference divided by pi. And that's how we do these as a function of, right? There are 2 equations. There's the one that we want. That's the first one in front of the word as a function of, perimeter of a square. And then we have as a function of, right? So we want P equals. Down here it says diameter of a square as a function of, so we want D equals, right? You want the word that comes in front of as a function of to be part of your equation, not the other way around. Okay, now we get into some algebraic equations that give us a geometric figure. So we have this x-axis. Right, we have a line and we have a vertical line. So we've seen these before, hopefully, and we're revolving it around the x-axis, so that gives us a conical shape. When you revolve a triangle, we get a cone. Right, so this is the graph of y equals 1/3 of x. Okay, then here's your random point x comma 0, right, and the vertical line. So the vertical line becomes your radius of your cone. Right, this is the radius of your cone. The vertical line is your radius. And what's going to happen is, of course, this from the vertex to that center point, that's going to be the height for your cone. Okay, so for part B, when it says express the volume as a function of x, right, we start with our volume cone formula, which is always 1/3 pi radius squared times height. That one you should commit to memory, right? Memorize that formula. So let's think about our different lengths that we have here. The height, what is the height of your cone? That goes from the middle of your triangular circular base up to the vertex. And if you notice, this is a horizontal distance, right? That is a horizontal measurement. And which variable always goes with a horizontal measurement? The x value does. So to find the height, I'm just going to look at whatever the x value is, because that goes from the vertex to the bottom of your cone. Now the tricky part is your radius, right? The radius is a vertical distance. What letter goes with a vertical distance? And when you have a coordinate, the y value. So the radius corresponds to the y value, right? And the y value is not just a y, but it is found by taking x and dividing it by 3. So down here for radius, that is 1/3 of x. That's how you find the radius, is by taking the x value and dividing by 3. Now, of course, this needs parentheses around it because it's a product, right? 1/3 times x. And now it's a matter of simplifying. So first we start with squaring your 1/3 x. And when I square 1, I get 1. I square 3 and get 9. I square x and get x squared. Okay, so I'm squaring the 1, squaring the denominator, squaring the variable. And I still have all these other things hanging out here. I have a pi, I have 1/3, and I have my x. So now I do my multiplication. which just says denominators times denominators. So 3 and 9, those are both my denominators. That's going to be 27. And everything else is a numerator. Pi x squared and x is pi x cubed. So that is my formula for this particular function, the volume of that revolved cone as a function of just x. Because that makes part C pretty easy. Find the volume when x is 9. Well, you just plug 9 in here. All right, and when you do this in your calculator and leave out pi, you get 27. 9, sorry, not 9 to the square power, 9 to the third power. I apologize, 9 cubed is 27 pi, which if you put that into your calculator, 27 pi is approximately 84.823. Okay, so you can either leave it in terms of pi or you can decimalize it. So we have a picture from your graph, right? Your algebra, a linear equation that forms a triangle. And when you rotate a triangle, you get a cone. The height of the cone is the x value, and the radius of the cone is your y value, which you always use the equation for, not the actual letter y. Okay. Now let's go to our rates. Here we have once again a cone-shaped tank. Right, so we have our cone-shaped tank with its vertex down, or this one works so good. And we know it has a radius of 5 because it has a diameter of 10 and it has a height of 8. So once again, volume of a cone as a function of its height. We start with that formula once again, 1/3 pi r squared h. But our other formula is the proportion. How does the radius relate to the height? There's always a ratio in cones. And when the radius is 5, I know that the height is 8. Okay, so I want to solve this for r, so we cross multiply. 8r equals 5h and divide by 8. The radius is always 5 times the height divided by h. Sorry, 5h over 8. And that's going to come over here into your r equation, right? We're going to replace r with that value, with 5h over 8. Everything else stays the same. I have an h here and a pi and a 1/3. Okay, and we're back to the same thing we had before, right? We have to simplify. So we square the 5, we square the h, we square the 8, we square all those parts. 25h squared over 64. Okay, so that's just the r part, and now I have all these other things to do as well. Okay, so just like before, I do denominator times denominator. 3 times 64. That is 192. And I have a number 25, I have pi, and I have h cubed. So that is the formula of your volume in terms of just the height. And that's important for part C. But for part B says, if it's originally empty, how much water is after 5 minutes? So that comes from our rate. It is being filled at a rate of 6 cubic feet per minute. So volume is 6 cubic feet every minute. And if I've been running the water for 5 minutes, that means I have 30 cubic feet of water in that tank. So now I can answer the question, what is the depth? I take that 30 and I set it equal to my equation in terms of height or depth. So 30 equals 25 pi h cubed over 192, right? And that was the equation that I made up here in part A. Now there are 4 steps. Number 1, multiply by your denominator. So we're going to times by 192. Step number 2, divide by 25. Step number 3, divide by pi. Okay, and I do this for a reason because students often mess up when they try to do it at the same time. And then the last step is to take the cube roots of both sides. And when you do all that work, we get an H value of 4 feet. 4.186 feet. And then after how many minutes will a tank be full? So I know that volume equals 6 feet every minute. So if I can figure out what the full volume is, that means I can divide that by 6, and that will be the time. So the maximum height is 8, so I'm going to use this formula. Right? And plugging in 8 for the height. And then I'm going to calculate this volume right here. So this is an actual number. It's going to go into my calculator. Let's see, control divide, 25 pi times 8 cubed divided by 192 is 209. So that's and change, 209.44 my calculator says. And what I want to do is divide that by 6. Because it's 6 feet per minute, and I get a time of 34.9 minutes as your time. Okay, so total volume divided by your formula of 6T, 6 cubic feet per minute. All right, the last ones we have are your probability ones, and these ones most of you like and we're good at, so let's don't take too much time. Random student will be an athlete. There are 28 athletes out of 78 total kids. 28 divided by 78 is 35.89, or 35.9% of kids want to be athletes. Okay, given that a student wants to be a doctor, so we are only looking at the doctor column right now. Only doctors in this one. Okay, it has to be a doctor. What's the probability of selecting a girl? So there are 12 girls that wanted to be doctors out of 23 total kids. So 12 divided by 23 is 52.17, or 52.2%. Okay, and our last problem says, given that the student is a male, right? Now we're only looking at boys, so we're only looking at the boy stuff. We have to select a boy. What is the probability that he will be an athlete? So we had 22 boys that wanted to be athletes out of 42 boys total. So 22 out of 42 was 52.4%. Okay, so if it says given, that means we can only look at that information. We cannot look anywhere else. We have to look in that column or in that row only, so we can get our probability. Okay, so hopefully by this time tomorrow, you will be sufficiently intelligent to do as good as you possibly can on your last major test of the year. Thank you and goodbye.